So this lesson, assignment 20, is on adding and subtracting rational expressions. First off, this got copied twice in here, so we'll cross that out. We're going to read this now. Two fractions must have the same denominator in order to combine them. Otherwise, they are not like terms. Adding two fractions that do not have the same denominator is like adding dollars to shirts, dogs to cats, x's to y's, or x squareds to x cubes. The good news about fractions is that you can always make them like terms. So when we talk about these adding x's to y's, if I had something like 3x plus 4y, we know we can't add that and there's nothing we can do about it. With fractions, we can actually create common denominators so that we can add them together. So we have super basic fractions and then we'll move into the new stuff. So here I have 2/5 plus 1/5. So the thing I'm adding together is fifths. I have two of them plus one of them is 3/5. So we're adding numerators, keeping the denominator. There are three of them and they haven't changed. They're still fifths, so the 5 stays the same. In the second fraction, I have 1/2 plus 2/5. Now, right now, I automatically see that I can't add halves and fifths because they're not like terms. Now, we want to use a certain property of fractions in that we can create as many equivalent fractions as we want. So I'm using this 1/2 as an example. If I have 1/2 and I want to make it into, let's say, sixths, which has nothing to do with this problem, we're just going to pick sixths. If I want to make it into sixths, I can multiply by 3 to create that 6. And if I multiply by 3 in the numerator as well, I'm really multiplying by 1. So I'm going to multiply across. 2 times 3 is 6. 1 times 3 is 3. And we've created an equivalent fraction. We can check that. Our 1/2 is equal to our 3/6. Nothing has changed because we multiplied by 1. So looking down at this problem, we want to make halves and fifths into something that we can add together. And this is called the least common denominator, or the smallest thing that we can make them both into. So basically, we're thinking about a number that we can multiply to get them to be, that will be the same number. So we can basically make them both into 10. So I can make a 2 into a 10 by multiplying by 5. And we have to multiply by 1, so we do 5 over 5. I can make a 5 into a 10 by multiplying by 2. So my first multiplication becomes 5/10, which is equivalent to my original 1/2. My second multiplication becomes 4/10, which is equivalent to my original 2/5. Now they are like terms. They're both tenths, so I can add them together. 5 of them plus 4 of them is 9 of them, and I have tenths. So this is the answer to this one. Now, just to make sure we don't, kind of oversimplify things, here I have a 6 and a 9, but 54, which is the product of 6 and 9, is not my LCD. Over here, 2 times 5, 10 was my LCD. Here we can choose something smaller. So we want to think about the smallest possible thing that both 6 and 9 go into, and that's 18. So my first fraction to get to 18, I would multiply by 3. And my second fraction to get to 18, I would multiply by 2, once again using that fraction that's equivalent to 1. So my first fraction becomes 15 over 18, and my second fraction becomes 4 over 18. So now we have 18ths, we can add them together. We have 19 of them, or 19 18ths. Now this is an improper fraction. We could make it the mixed number 1 and 1/18, but there's really no reason to, because you're going to see with the variables we can't even really change things like that. So we're going to now work into rational expressions, but there's that short section to do in Delta Math now.